Good afternoon, everyone. Uh-huh. My name is Olatubosun Egberinde, and I'm very excited to be here. Probably because this is something I've been really looking forward to in Nigeria, in the sense that I really want a PHP community to be well established in Nigeria. And seeing Laravel Nigeria do this, it's really making me very, very excited. So can we clap? So let's clap. Yeah, so I'll be talking about asynchronous PHP and why you should care about why you should care as a PHP developer. I'm very sorry we have to rush a lot of things, but definitely my slide will be made available to every one of us, so we can just go through them and um, look at it later on, because everything I'll be saying, some of them might not be clear to you immediately, but as you begin to look into it, it's going to get clearer. So this is a topic I started looking at probably a year and a half ago, and before it wasn't that clear, but now let me say it has gotten better, and I would really like to share with you guys. So about me, I'm a PHP developer. I write JavaScript a lot and TypeScript a lot as well, and I'm in a love relationship with PHP. I really like PHP a lot. In fact, the people around me really know that. And I'm a student, electrical student, and lastly, I'm unemployed. Yeah, so I'm unemployed. So you can find me on Twitter and GitHub as well. So without wasting time, I'm going to rush a lot about you, not the about you spontaneous, but about you. So I believe everyone that is here, we are PHP developer, we are PHP enthusiasts, or Laravel developer, or people who have interest in PHP. So I believe I'm with the right audience, right? Okay. So about my talk is just like an aggregated, let's say it's an aggregated talk from around the PHP community about topics that are concerning asynchronous PHP. So and then it's not a one size fit all thing. These are just my own opinion about asynchronous PHP generally and what I think you should do about it. So you don't necessarily have to follow this talk. So our journey today basically is going to be about PHP. We talk about traditional apps in PHP, and we talk about asynchronous apps, and then how you can get started, as well as the building blocks, and then how we can apply these things. So let's talk about PHP now. I believe the reason why I'm bringing this up is most of us are not really updated about what PHP is, and it really affects the thing we think PHP can actually do, because the knowledge of what we know about a tool we are using will affect how we are going to use it. If you don't know it well enough, you might not be utilizing some part that is offering to you. So that is exactly why I'm bringing this talk up. So PHP now, I want to cite a quote from the maker of PHP himself, the PHP's dad, and he said, "I saw PHP as a thin templating system." He said, but the world disagreed with me. And looking at where PHP started from, if you read the histories, PHP wasn't meant to be a full-form programming language. It was just meant to be a templating system over C language. So, but looking at where PHP is now, it has really gone very, 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 very far. So in 2019, many things have happened to PHP. We have the likes of WordPress, we have different CMSs, and then we have different frameworks built on PHP. So I captured this image from the recent Octopus. In case you are still doubting the interest of people in PHP, if you go on the Octopus website, you actually see that the fourth most popular language on GitHub in 2019 is actually PHP. So in a way, the interest of people in PHP is actually still there, if you can see that. So moving on, we have the likes of a better typing system now in PHP. In case you don't know, not that good, but it's still coming up. We have a robust CLI application. You can build a very wonderful CLI application with PHP. The likes of Artisan, we have the Symfony console component. All these things are powerful tools you can use to build CLI applications. We have long-running processes are supported. FPM is there to make your PHP a little bit faster on over Nginx. We have the likes of JIT that is coming in PHP 8. We have preloading already in PHP 7.4, and then we have 2x speed. In case you are still using PHP 5, move away from that thing and go to PHP 7. Thank you. So we are looking at traditional applications in PHP. The reason why I'm bringing this up is I want us to see the problem that asynchronous PHP is actually solving, because if you can't really get it, if you can't really know the difference between them, we might not be able to think about how we can apply this knowledge. So if you look at this image, you can see that this is just a sample of a basic Nginx setup with PHP. What we actually do is that there's a client making a request. The request is going to hit Nginx, and then Nginx is going to forward that request to some. It can spin up multiple processes for FPM, and then it's going to return the response from FPM to handle that request, and then it's going to send the response back to the client. This is a basic thing. We know that PHP, that is how it handles requests. It depends on a web server. It has to have a web server for it to complete its tasks. So looking at this now, there is I don't know if you can see this code well, but if you can't see it well, don't bother about it. The slide can be shared later. I highlighted some red lines there, and then the name of the function that I'm displaying is get user full names, and on that red line I'm showing something there, and is a file get content. Now, as little as this code is, it is actually possible for this code to take 40 seconds to load. Why? Because if the file I'm loading is too large, it's going to actually take some time for it to load all the file into the memory, then continue with the operation that is happening there. So that means on that red line, my PHP application is going to pause for a bit. That means it's going to stand for a bit. Your processor is doing nothing, and then it's going to go on like that. Same thing with the second red line, and then you have me calling a database for all the users. So I'm trying to get all the users. These are waiting points. I highlighted the red lines because they are waiting points within your application, and I want you to note that word, waiting points. So moving on, even though there is been a major improvement in PHP, PHP still isn't what some developers want on the performance side. I've heard people talk about PHP concerning performance. PHP is not fast. PHP is not concurrent. I can't do some heavy tasks. I can't do some big tasks with PHP and the likes. So I've heard that a lot, in case you've heard that too. So some of these things that I've heard, those are the things I've highlighted here. You can't really do concurrent stuff. Can I do async in PHP? Don't do async with PHP. Just use X, use Y, use Z. You know the answers to those X, Y, Z, right? Do you know them? Okay, don't worry if you don't know them. So some say PHP is too slow for modern application, but I really say that is not true. That depends on your knowledge about PHP. So moving on, we generally believe PHP is very slow. That is the belief. In fact, most of we PHP developers, when we are being challenged that PHP is slow, we don't have anything to say about it, because you can't actually give proof that, okay, this thing is what? This thing is actually fast. So that's the way it is. So moving on, some solutions over time that they develop for PHP being too slow. We have the likes of caching. Most of us, we use Redis in our application, if I'm correct. We use memcache. We use server client-side rendering to make to gain a little bit of performance on the client side. Then we use load balancing or auto scaling or all those things. Or we go vertical. We use more hardware. Probably you are using 2 gig RAM before, you go by 6 gig of RAM or anything like that. Trying to just level up on that performance. So these are things that they are in the traditional way of writing PHP code. These are the deficiencies. These are the things we do encounter. So, but I during my study, I discovered that PHP actually has within itself, for it to scale up in the aspect of performance. If something that you need is actually performance, PHP already has what it takes within itself to be better in performance, and those are the things we'll be talking about now. So let us enter an async. So let us enter async rather. I want you to look at this particular slideshow. So I'm just modeling a sample request, like in the traditional app, which is a synchronous application, and then in an asynchronous application. So I want you to look at it very well. So we are trying to make a request to get something from the database and then render it on the client side. So that is just the task. So on the synchronous app, this is how it's going to go. You receive a request, you process the request, you read from the database, and then you render the view, you send back the response. That's how it works. On the asynchronous app, what you do, you receive a request A, and then you process the request, you go ahead, you read from the DB, and reading from the DB, like I said, is going to take a while. An asynchronous app, knowing this, is going to pass the control back to what is called the scheduler. The scheduler, knowing that this is going to take time, is going to go ahead and do another request. Is going to go ahead, read from the DB. This is also going to take time. Before it's done, that one is already done, and then it's going to go like that, switching between all of them until all the responses have been handled in the same span of time. Now, this synchronous app is taking the same time, and then the asynchronous app is also taking the same time. But what is the difference? one is handling 2 requests at the same time, the other is handling only what? Only 1 request at the same time. So now, moving on, you might ask yourself, why should I even care about this? Why should I even care about it? And the only reason why you should care about it is that there are IOs everywhere. Yeah, I love Toy Story actually, if you like it too. So the reason is that IOs are everywhere. And what are IO? IO means input output. Even though most developers don't really take care, we don't think that way anyway. But people that are writing Go, that are writing Node.js, they quickly have that mindset because the tool they are using actually it provides them easy access to actually quickly start thinking in that kind of way. But we PHP developers also, we can work on this mindset to know that okay, there are some things that I'm doing that they are IO based operations, and there are some things that are just calculation based operations. So moving on, the fact about IO is that they reduce performances in your application. Let's say for example you are reading from a database, that's an IO operation. You are reading from a file, you are writing to a file, that's an IO operation, and they reduce performance a lot. So they are very common. And the example, you have external API calls, reading or writing to files, database calls, spawning child processes. You can add yours. So I gave example in code in case you are trying to relate with them. The first one is this. This is a request to create a starter file, and if you see on that line, I said storage put request input. Let's say for example, when my code gets to this line, when my Laravel application gets to this line, it's going to wait a bit. It's going to wait before that file will be put there. Now I'm going to explain what involves what causes the waiting, so you can know what I'm talking about. There are other examples. This one is fetching something from the database. This one is creating something in database. This one is spinning up a child process to prune Docker containers. And then this example is just fetching something. Let's say it's calling an API rather. Yeah, you are calling an internal API, something like that. So the idea of this problem is the fact that CPU calculations, they are very, very fast, but the IO operations are what? They are very, very slow. Now, you might be looking at it like, why should I even still care about this? The fact is that what you do most time in your application, they are IO operations. Like, they are IO operations. So now, let's check this out. Now, I believe one thing I recommend is every developer should actually know about this image. If you care about performance, you should take time to know what this image is all about. If you look at that one CPU cycle, that is a calculation for your processor. One CPU cycle is going to take around 0.3 nanoseconds. But if you go down, starting from that place where that red line is starting, you will see 50 to 150 microseconds. You can see that the time is actually increasing. Now you might be asking me, what does latency mean? Latency means on the low level. Don't mind me, I'm an electrical student, so let me explain that part. So on the low level, if your processor is trying to request something from your hard disk, the time is going to take for the hard disk to start responding is what? Is 50 microseconds. Do you get what I'm saying now? That is the meaning of what you are seeing there. So the deduction from this image is the fact that latencies grow at I/O, and then time is wasted, as well as while your CPU is waiting, it is actually doing nothing. You are wasting that CPU, and then other operations are being blocked in this process. So this is an example of what we call a blocking operation. So if you have heard about it in Node community or Go community, you say this is a blocking operation. You are performing a blocking operation. That is what this is talking about. So, and the trouble that we have is that we think we have that time, but our users using our app doesn't really have that time. We have to save a lot of time. So a performance app reduces this waiting time, and it does this by not having to wait at all. That means it can switch between the process that is currently performing. If it's going to delay, it can switch to other thing and go ahead and do them. This is what we call a context switch. Like, it's switching between different processes to do whatever it's trying to do. So I don't want to go into this low detail, but this is an example of what we call concurrency. If you are talking about concurrency, it doesn't mean a parallel execution whereby you are executing the same thing in the same time. This one is that you are doing many things at the same time, and you are switching between each of them. When one is going to delay, you are going to go to the other one and do that one. If it's going to delay, go back to another thing and do them. That is what concurrency is all about. So concurrency allows us to perform operations that require waiting in the same span of time. So a simple summary is that synchronous style of writing PHP application is actually blocking, and then asynchronous is non-blocking. So if you are going to scale up in performance, you need to check what are the things that are blocking within my PHP application. So those are questions you have to answer. So how can I get started? We are moving on. How can you get started? So some options we have to do as in asynchronous stuff generally is that we have Node.js, or we have Golang. I've heard people talk to me about this. Why can't you use Golang or use Node.js? And then you can decide not to use Node.js, or you can decide not to use Golang, or just use your beloved PHP. So, but the thing is, you don't have to use other languages for async stuff or for concurrent stuff if you don't want to. Don't let anybody tell you, okay, don't let anybody tell you. But the fact is that if you don't want to, as a PHP developer, you don't have to use other language. For example, there are some companies who don't want to spread their stack on multiple type of technologies. If you are a company like that and you want to build up your stack on PHP, you can do it with what? With the PHP that you are working with. You just have to know some concept. Once you know some concept, you can just go ahead and do that. So the next thing is that PHP doesn't have, you might be thinking, does PHP have anything in the core that can make it do that? No, it doesn't have anything that has to do with async. It doesn't have it within the core. But PHP has tools within itself that you can put together, and then you can use it to do asynchronous stuff. So an example of this is PHP. This is what I was talking about. Most of the codes I will be showing, it will be on this. So React PHP is just is a low-level library for event-driven programming, and it supports PHP as low as PHP 5.3. It's based on reactor pattern. Same way Node works, it works the same way Node works. If you have worked with Node.js before, React PHP works similar way with the way Node.js works. So it uses an event loop. It is coming baked in with an event loop. I'll be explaining what an event loop is later. It comes with streams. It comes with promises. Just like you can do promises in JavaScript, you can do promises in PHP too. No extension is required. You don't need any extension to. It is written in pure userland PHP. So the next one is AMP PHP. AMP is a non-concurrency blocking framework for PHP. It is coroutine based. If you have used an event loop, supports promises as well, and it supports asynchronous iterators. Same thing with streams, and it's synchronous like. That means you don't have to use then, just like in JavaScript. You can use something that looks like async await for something like that. So you don't need to attach then to your promises. So that's what that one is talking about. And then you have Swole. Swole is a coroutine asynchronous programming framework for PHP. This one is a PHP extension actually. It's not written in userland PHP. You have to install it with Peco, the extension manager for PHP, for you to have it. Swole, I can say Swole is very, very fast. Swole is very, very fast. So I don't want to talk much about it. And it supports channel. If you use Go and you know about Go channels, it works similar way like Go channels. So for this talk, our focus will be on React PHP. So building blocks. The first one is the event loop. What is the event loop? Is the core of an asynchronous application. You might have heard of event loop in JavaScript. You doing JavaScript, or you've watched a video about it. So event loop is just a scheduler. It schedules what is happening. Like it schedules what is going to happen next. It schedules, it listens for an event, then it triggers the listener. So it's the one who does all those things. When something is going to delay, that's why when you are performing an XHR request from your front end, you are going to get a promise. You are going to get a deferred operation. I don't know if you understand what I'm saying. If you have done Ajax on front end before, what you are going to get for Axios, you are going to get a promise. Am I correct? Yeah, you are going to get a promise back. That promise means you can go ahead and do whatever you want to do, and then you can wait on the promise later. You get what I'm saying now? So the event loop handles all this execution of processes. It handles all the context switches between processes. So it is based on events, and the way event loop works is only an instance of an event loop can run at every instance of time in your application. So that means you run it once, you create it once, you pass it around, and then you run it once. I will explain what others I will explain what all those things means later. So it runs till it has nothing to do, or it stops, or it errors out. So it handles low-level signals to probably all these termination signal and interrupt signal and all those things for processes. So this is an example of a code in event loop. You create it once, you pass it, then you run it. So streams, I don't know if you've heard about streams before. Streams are on-demand data access. They provide on-demand data access. They provide data in chunks, processing of data in chunks, and then They provide better wrapping. I don't know how much you know about PHP, but PHP supports low level streaming too. So this stream provide so a better API for you to use stream. So this is an example of streaming code. And then promises just like the way you know it in JavaScript. So these are the low level components that build up an asynchronous application. So applying all this, you might ask, should I use async in my PHP app? I will say it depends. What did I say? It depends. If your application is better off written with Laravel and you don't need to mix anything and it's going to serve your customers right, it is fine for you to do it that way. So you can just take that route and go. So, but if you want to use your async components in your already existing traditional apps, you can just try to check it out. Some of these async tools, they support your traditional apps too. And I'm going to show a demonstration here of how I use it in a sample web scraping. I don't know if you are into web scraping, you might try to just check it out. So if you look at this is an example of a scraper rather. That function is going to perform scraping on 3 URLs. So those are 3 URLs. I'm going to be making requests to those websites and then I will get content from them, then scrape out the things I want from them. Now, if I'm going by the way Gozu works, Gozu is a blocking HTTP client. So that means when I'm making a request, I can't make another immediately, or I can use Gozu async. But the Gozu async also is not that optimizable. So that's what I can say about it. So if you look at that, that means if I'm fetching the first one, I will wait. If it takes 1 second, I'm going to wait another 1 second. I'm going to wait another 1 second, making what? 3 seconds. Do you get what I'm saying now? So that is a disadvantage for me because I can't let my users be waiting for 3 seconds for them to get over what? One request. Do you get what I'm saying now? So, but I rewrote this in Async, and this is how it looks like. So I have the URLs. Then I'm using a tool called it's called Boss Browser. It's written based on React PHP. What it does is an asynchronous HTTP client. So when it makes a request, it returns a promise to you, and with that promise, you can go ahead and do whatever you want to do. And then you can You can feed in all other URLs. Now you can see I collected all the promises there, and then right there you can see I said await all. In JavaScript, you can await many promises too. I don't know if you've used that before. You can await many promises. So that is exactly what I'm doing there. Now, if it's going to take this app 1 second to fetch the first URL, then it's going to take this app 1 second to fetch all of them. I don't know if you know the calculation, because all the requests are sent at the same time, and then it's blocking to wait on all the requests. So that is exactly what happened here. And with this, I'm able to achieve 2 times faster on the same request. Do you know what I'm saying now? So this is an advantage that asynchronous tools, this is an advantage they provide for us. And you can see I used it in a native application. So the first caution I want to say here is not all these things are compatible in the current PHP that we write. Laravel, you can't just use it anyhow. These things, you need to study them to know how to apply them. The second thing is it doesn't make your app fast automatically. You have to have the knowledge on how to apply these things. Even in front end, if you don't know how to use your promises very well, you'll still be having some unusual lags. So all these things, you need to know how to apply them very well. The third one is, this is not a new thing and you don't have to apply it. It's not like it's a do or die thing, like I must apply this thing. If your app is better off on what you have currently, just go by that. And if you think you need to scale up, just do that. So another way you can build some services out of Async PHP using it supports WebSocket. If you need WebSocket, currently Laravel WebSocket is written with React PHP, Ratchet PHP that depends on React PHP. So that's an example of an application. And by the statistics, it is actually very, very scalable. It's very, very scalable. So you can use PHP Process Manager. It's also written on React PHP, and you can use message queues too. Or you can go full-blown async, even though there is no framework for us to do something like this. So, but currently I'm working on something that because I don't want people to go through the level of high barrier in learning anything that has to do with async the way I went through it, and the community is not really that ready. So all these things, putting them together, there are components that are available there, but putting them together is something that is very, 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 very hard. So I'm working on a solution whereby you can use the Eloquent that you used to know. You can use it, but in an async manner. So what are not possible when you are using this thing? You don't have PDO, you don't have all these gozu. You can't use gozu. You can't use forget content. You can't use all those things you are used to, because it's a new kind of mindset, new kind of approach. So this is an example of the eloquent that we know. And then when I rewrote a part of eloquent, and then I'm able to get something like this. So you are retrieving a user, then it's going to return a promise, and then you are attaching then to get your stuff out. So this is where I'm going to, or it can be like this too. This is also an example, coroutine like. So these are useful links for you. You can put them down. I compiled some lists and you can just go through them. So okay, you want to. So this is the React PHP community. In case you want to join the community, they have a Jitter account now that is more accessible. In case you are using any of the tool and you want to ask a question, you can just go there, visit that link and drop your questions there. And the first one contains some list of tools you can just check out, or articles I compiled. So these are key takeaways. You can see that later. And thank you for listening. Even though it's fast, but thank you very much.